Welcome to class number 19. In this class we will discuss about basic BGP path attributes and BGP path selection process. So whenever a route is advertised by the BGP process, it can attach some attributes so that the route received by the BGP peer will use those values to make the routing decision to see which route it needs to prefer. So for the path attributes, we can divide them into two main categories. One is well-known and another one is optional. So the well-known categories must be supported by all the products whoever is implementing the BGP. If it is like Cisco, Arista, Juniper, Fortinet, Palo Alto, or whatever the device, if it is running BGP, it must support these well-known attributes. Okay, the optional ones, they are not mandatory. For suppose if you are sending some optional path attribute from Cisco peer to another Juniper peer, and if the Juniper does not, there is no mandatory rule that it needs to support these path attributes. Okay, then in the well-known, again we have two subcategories. One is mandatory and discretionary. So well-known mandatory attributes are next hop, AS path, origin. So when we say mandatory, it must be advertised to the peers. So for suppose, let's look at this topology. So R1, R2, R3. So there is a BGP session between R1 and R2 and another BGP session between R2 and R3. So when R1 advertises a route with well-known mandatory attribute, it must be including all this information: next hop, AS path, and origin. So when the R2 receives it, it must understand because it's well-known attribute. And mandatory means whenever it is sending this route to another router, it needs to include that information. So these attributes you should see for any BGP route. Any BGP route, you should see these attributes. Okay, let's see the discretionary. Discretionary means, so it could be well known. So for suppose if R1 is sending a route using well-known discretionary attributes, R2 will understand it because well-known, it should be supported by any type of router. So R2 understands it, but whenever it is sending that update to R3, it is not mandatory to forward that information. So let's say there are like two in this list: local preference and atomic aggregate. So if R1 is sending a route using the local preference, R2 will understand it because it is well known, it is supported, but it may not forward it to R3. Okay. And next, optional. As the name says, it may or may not understand by the routers. For suppose if this is Cisco router, this is Juniper, this is Arista. So optional attributes, there is no mandatory rule that all the R1, R2, R3 needs to support or understand these attributes. So in this we have two types: transitive, non-transitive. Transitive means whenever R1 is sending that, R2 will forward it to the R3, means it can propagate to other peers. In the non-transitive, if the R2 does not understand this attribute, it will just discard it because it not understand it and it won't forward it. Okay. So transitive will be passed to the peers. Non-transitive, if the router does not understand this, it will not forward it to the next BGP peer. So to make it easy and to understand, I have a table here. So here is the type of attribute, and then when the router receives the route and what it will do when advertise the route for this particular path attribute. So well-known mandatory, every router must understand this and should include whenever it is advertising the route to the peers. Okay. Well-known discretionary. It must understand these attributes, but it is not mandatory to include that information when it is advertising the route to its peers. Optional. Optional means the router may not understand it. Okay. If it is transitive, it will, whenever it is advertising that route, even though it is not understanding, it will include that information when advertising that route to the its peer. So in this case, it will say it is like partial. It does not understand it, but it will forward that information to its peer. In the optional non-transitive, if the router not understanding this or supporting this attribute, it will not include. Okay, it will just discard it. So that whenever it advertises a route, it will not include this attribute for that route. Okay. So let's take one example, local preference. So local preference is coming under well-known discretionary. So if R5 is sending a route with the path attribute of local preference, R3 will understand it because it's a well-known. R3 will understand that, okay, for this particular route there is some local preference, but when it is sending that route to R2, it is not mandatory to include that local preference information for that particular route when sending it to R2. Okay. So let's look at this topology. So here we have R5. Okay. So R1 is advertising these two networks to R2 and R4. R2 will forward that information to R3. R4 will forward that information to R5, and R3 also forward that information to R5. So in R5, through BGP process, it will learn about PC1 and PC2 networks from two sources. So it will learn that /24 can be reachable from R3. Also, the same network can also reachable from R4 as well. So now R5 needs to decide which route it needs to prefer. So now BGP will go through the path selection process. So this is the process it will go through. First it will check if any of the route has any differences in the weight value. Okay. So if administrator configures any weight associated to any of these routes, it will choose the route which has the highest value. If there is no weight configured or the configured weight is same, then it will not become a tiebreaker to decide which one to choose. Then it will go and check local preference value. So if any of the route has highest local preference value, that will be chosen. For suppose if this router has 50, this route has 100, then BGP process will choose the route which has the highest local preference. Okay. If there is no local preference configured or the configured value is same, for suppose both are having 100 and 100, which is the default value. So in this case, we don't have a tiebreaker. Weight is same, local preference is same. So then it will check whether the route is locally originated or not. So in this case, both routes coming from the eBGP. So they are not local to the they are not locally originated on the R5. So they are coming from two different peers. So this is also not a tiebreaker. Then it will check AS path length. So when we look at the route coming from R3, it is coming from 1, 2, 3, three autonomous systems. But when we look at the route coming from R4, it is coming from autonomous system 1 and 4. So it will choose whichever has the shortest AS path length. In this case, it will prefer the route coming from the R4. So in this topology, the route learned from the R4 will be preferred. For suppose in another topology you have the same AS path length for the both, then it will go through the next one. So it will check how, so in this case R1 is originating this route, right? So we use the network command on this router to inject the route. So it will be preferred. For suppose another route is added into this using the redistribution, so this is the order it will prefer. It will prefer the routes added using the network command over the redistribute. So EGP is not used now. Exterior gateway protocol, it's an old one, so you can ignore this. So if a route is added in the originator router using the network command, it will be preferred over the redistributed route. So if there is no, if both routes are added using the network command or both routes are coming from the redistribution, then this is also will not be a tiebreaker. Then it will check the med value, multi-exit discriminator. So if one route has the lowest med value, then it will choose that. But if both having the same value, or if both does not have any med value associated with them, then this is also will not become the tiebreaker. Then it will check the next condition. It will prefer the eBGP routes over iBGP routes. So if both are eBGP or if both are iBGP, then also it will not become the tiebreaker. So then it will check if the routes are learned through redistribution of OSPF or EAJRP routes, they will have some metric value associated to it. So if metric is low for one of the route, it will prefer that one. But if the metric is default metric or does not have any, if both have the same value, then this will also will not become the tiebreaker. Then it will go and check whatever the oldest route. For suppose one route is learned 5 hours ago and another route learned 10 hours ago. So in this case, it will choose the oldest route. But if both routes learned at the same time, then it will check the router ID. Whichever the route advertised by the router ID, the router ID of the router, it will choose the lowest one. If this is also matched, then it will check some concept of cluster list and then the neighbor address value. But most of the cases, it will end up until this part or this part only. Okay. So yeah, you just need to remember or like have some reference to this path selection process. Okay. So if someone asks like what is the BGP path selection process, or if you are working on some BGP topology and you want to make sure which route will be installed into the routing table, you need to check all these priorities. So let's look into our lab topology. So on R5, I issued a command show IP BGP neighbor from R3 IP. What are the routes we are receiving? And the same command I have given for R4. What are the routes we are receiving from the R4? If you can see, we are receiving 1.1.0, 2.0, and from R4 also advertising the same thing. So if you go through this, so there is no weight value associated to any of those routes. So this is not the tiebreaker. Next, BGP will check if there is any local preference value differences. So if you see, all of them are having the default local preference value, which is 100. So this is also not tiebreaker. So it cannot decide which one to inject into the routing table or prefer. Then it will check if there is any of the route locally originated. In this case, both are coming from different autonomous system and it is not locally originated route. So this is also not helping to decide which one to choose. Next, AS path length. If you see, the AS path length here is 1, 2, 3. So this route is crossing 3 autonomous system. Here it is only crossing 2 autonomous system. So based on the BGP path selection process, it should choose the shortest one. So in this case, shortest AS path length is this, because it only has 2 ASs to cross. Here it is 3. So it will install this route. As you can see, star means all are valid routes The best one will only have the greater than symbol active. So these will be installed into the routing table. So BGP path selection process has selected this route to be added into the routing table so that R5 will forward any packets to these destinations in this direction. So let's examine the routing table. So when we do the show IP route on R5, we can see that two BGP routes for PC1 and PC2 networks. Next hop is 45.45.1, which is R4 Ethernet 5. Okay. So yeah, just remember all the BGP classification for the well-known attributes and the optional, and inside well-known subcategories as well. Okay. Then you can examine the current lab topology to see how the BGP path selection process selected the route towards R4 AS path length. Then do some research how weight and local preference can be used to influence the route preference in BGP. Okay. Yep, that's all for this class. And in the next class, we will discuss about redistribution. Thank you.